Hello everyone, welcome to the third chapter, and the objective of this chapter is to discuss the hashing in computer science, in computer forensics. Hashing basically, let me open the, yeah. Hashing or basically is used to determine or to verify the identical nature of any media. You basically need to compare the acquired image from the you need to basically compare the hash value of the acquired image from the copy of this basically image file. At any step during your forensic process, even in the code, you need to prove that you maintain the integrity of the data, and you have not intentionally or unintentionally altered or changed any content of the acquired data or the acquired disk basically. Because since you are investigating, you are not supposed to edit the acquired evidence file. You are not supposed to enter, write or delete anything. So you need to prove, you need to maintain the integrity, and you need to prove that you have maintained the integrity of the data. Hashing process or hash is just like the biometric identification of digital files, folders or even drive. It is actually mathematically derived from the contents of the item being hashed and is displayed in a set of numbers and letters. Basically, there are three known hashing algorithms out there. These three algorithms are very famous, and one is the MD5, which is message digest 5. It is 128-bit 32 characters algorithm. The other one is SHA, secure hash algorithm 1, and the secure hash algorithm 256. Well, the hashing technique and these algorithms are not only limited to computer forensics only, but these basically algorithms are used in verifying the downloaded file to confirm the information, and an encryption. Encryption is the encryption is the application of these type of basically hashes out there. You might have already heard the name MD5, SHA1, SHA256, and there are many other algorithms out there. Altering the content. If you alter or change or make any amendment in the content, in the disk content, then the hash value will be changed. But if you change the file name or even extension, it will have no effect on the hash value. So if you basically alter the content, if you basically remove a single character in a document or even change a pixel in an image, it will basically change the its hash value. But there is an exception. If you basically change the name, you are allowed to change the name and even the extension, because changing the name of the file or changing the extension doesn't change the actual content of this file or this image file basically. So you are allowed to change the name, the extension, but you should not alter the content. And hashing is a technique to verify whether the content has been changed during the investigation and analysis process, or the content has not been changed, or it is intact as it was acquired at the very first time. So in the previous chapter you have seen the process to get the image, the disk image, and now in this chapter you will see how you basically verify its hash value. Hashing process is very crucial in computer forensics. You need to you need to hash every value, every file, every single file, even the disk image must be hashed. and you know, and you need to verify in the code that you did not alter the evidence in some unknown way. So the tool that I'm going to use, let me open the here. The name of the tool is Hex Workshop Hex Editor. Since we need to find out the hexadecimal values of the image, of the created image that we did in the last chapter, so this is one of the very known tool, basically Hex Workshop. Simply it is actually a hex editor. You can alter the file, you can alter the hexadecimal values, but altering the hexadecimal values is not our objective at this moment. But you know, if you are analyzing any malware, any virus, backdoor, remote basically RAT, remote administrative tools, then you can verify the functions by analyzing its hash values. But at this time our objective is not to analyze the hash values to find out the malicious file, the viruses or malware. Well, so let's do it. The process is very simple, as you have already basically let me do the process. You already have the hash value at the very first time when you have created the image. Now let's suppose you have sent this file to someone else. You have transferred this file via CD drive, via you have uploaded this file on cloud, and someone else from your organization has downloaded this file, and he or she has performed the investigation, and now the result with the image file has forwarded to you again. But now you have to check whether the file that has been sent to you now is the original one. So you need to verify its hash. So the hash value that acquired at the very first step when you have done the FTK imager, you need to copy, you need to save this computed hash value, because this is the original hash value. You need to follow this hash value throughout your investigation. So now let's say this is the file. I need to check the hash value. What I'm gonna do is I'm just going to the hash workshop. I'm going to open the image, this image. It is here x.ms.dos shows that this is the FAT32 file format. Its hex values are here, and here it is returned that it is FAT32. If the file is NTFS, then you will see the NTFS written here, and this all basically shows the information, the structure information of the drive. Here you can see the information given about every offset values. Alright, so this, alright, now we need to compute the algorithm values. Generate checksum, click on tools and generate checksum. Here there are, you can see that the list of algorithms are there. Checksum 8-bit, MD2, MD4, MD5, SHA-8-1 160-bit, and SHA basically -2, and there are many other things, but anyways 256-bit. But our objective is since we are working with MD5 and SHA, then I'm going to select MD5, then SHA. I need to generate the checksum, the value, the hash value, so that I can match the generated hash value with the previously acquired one. We need to compare these values. I'm gonna generate it. So again, this process may take few minutes, and it's all depending on the size of the drive of the of the image, basically acquired image or created image. So this is the process. This is how you basically in the last chapter you have witnessed the process to get the to create the a disk image, and in this chapter you have seen you are looking at how to verify the hash values. You should keep in mind that after taking anything, after taking any step, after investigating anything, after after working on the evidence file, you should verify the hash value, whether you have changed the content, the integrity or not. If you see a difference, then you should basically hands up, because something wrong something wrong basically had happened. So calculating the hash value is very important in computer forensics science. Alright, so here you can see that it has generated the files SHA-1 160-bit and the MD5 128-bit. Alright, let me copy the generated hash value, and I'm going to enter another notepad file. This is first one is the MD5 value, the second one is the SHA-1 value. As you have also already witnessed that in the previous chapter that SHA-1 was failed in the previous chapter to verify, so it should not verify it again, because if one time it got failed, then other time it should be failed. Let me check. This is the MD5 0457A 8370760852. Alright, EB26 it seems okay, while the SHA-1 checksum seems failed to verify. As you have already witnessed in the previous chapter, it was failed to verify, because every time you generated SHA-1 checksum, it says it gave the another detail, a new hash value which should not be there. So this is how you verify the integrity. Here you can see that the data is not as it is not real. Something wrong had happened. Whether it is unintentionally or unintentionally, this is altogether a different topic, a different discussion, but the data has been changed. This is the point here, that the data has been changed. Now I'm gonna close it. As I said, changing name doesn't has any effect, so I'm gonna change the name here. A name change, it's USB, just USB. Alright, MS-DOS FI32, generating the checksum again. Let me generate both. It is working. So here we go. It has generated the another hash value. Here the document is USB, as you have seen that I have changed the name of the file. But since, as discussed in the slide, that altering the if you change the name or even extension, it will have no effect on the hash value. But if you alter the content, then the hash value will be changed. So I have not altered any content, I have just changed the name, and let's see if it has any difference. It seems no difference. Here you can see, comparing the last hash value with the new hash value, you can copy it and you can verify with the previous value one. Here it seems no difference at all. Let me, here you can see this, both hash values are same. I have changed the name, but it has no difference. So changing the name or even extension has no difference, will make no will not affect the hash value. But if you change any content here, then you will see a difference in the hash value. So you can even verify my words. You can do, you can make changes and save the file, then again compute the MD5 hashes. You will see the difference in the hash value. Well, this is the process to verify the integrity, to check the value, the evidence, the image file, and this is how you maintain the integrity of the data, by keep an eye on the evidence file, on the acquired data file. So see you in the next chapter, because in the next chapter we will be analyzing the disk image. Now we have acquired the disk image, we have the disk image, we have basically to verify its integrity by using the hashing technique, by hashing process. Now we need to look into the disk image, what actually present in the disk image. So see you in the next chapter. Till time,